Okay, let's try another example. So this is another second order, right, differential equation. It's a homogeneous equation again because the right hand side is 0. Uh, so let's use the characteristic equation. So characteristic equation, it's also called the auxiliary equation in some books, but this book uses the characteristic equation. So if you see auxiliary equation, it's the same thing. It's the quadratic. It's a quadratic equation basically, quadratic polynomial. Okay, so the characteristic equation is going to be r squared plus 7r, right? R is the first derivative, minus 18 equals 0. So again, right, y double prime, that's this guy. Y prime, right, that represents this guy, right? It's really r to the first power. And again, no derivative, so no derivative here. And again, this is, again, just goes back to factoring, your factoring techniques from algebra. So let's see, this is 1, the coefficient, the leading coefficient's 1. There's no GCF, so we can definitely unfoil, right, or factor. R times R is R squared. And this looks like 9, 2, and let's see, probably plus and minus. Right, and again, we know because 9 times, right, we're looking for two numbers that multiply to negative 18 and add to 7. So 9 times negative 2 is definitely negative 18, and 9 minus 2 is 7. So here are our two factors, and we set each factor equal to 0. And these are pretty easy, all right, because we definitely know r is negative 9, so that's our first root. And our second root is 2. Again, obviously distinct roots, just like our last example. So using our same theorem, I think was 5, our general differential equation is C1 e to the r1x. So my r1 is negative 9x plus, right, this is a linear combination of C2, some coefficient, e to the r2x, and my r2 is 2, so I have 2x. And again, I think I want to say, I called that green last time, right? It's that guy. And, oh, I don't know, I think it was purple I used for 2. So again, this is the general solution. So let's try another problem. Okay, so I'm fixing this problem. Thank you, Kendall Porth, for finding that. I'm not sure what happened there. I don't know if I hit pause or skip. But yes, if you didn't notice, or I'm changing the video because example 3 completely skipped and it went to 4. So I just finished example 2, which this is the same as the very first problem. So I left this the same. So now I'm going to do example 2, or example 3. And I used y double prime plus 10y prime equals 0. So here's our linear differential homogeneous equation, right? Because we have 0 on the right hand side. So we can use our characteristic equation, right, to help us find our roots of this differential equation, or we can again transform it to a polynomial. So let's say r is y prime, so that means this is r squared plus 10r equals 0 again. So I'm letting r be the first derivative, so that means r squared is the second derivative. And again, we want to write it as a polynomial because we know how to work with polynomials. They're easy to factor, if, of course, factorable. So here we can take out a greatest common factor of an r, and then we're left with r plus 10. And our zero factor property says either r is 0 or r is equal to negative 10. And again, I'll just name this as r1 and this one as r2. So now that I have my roots, I can definitely write a general solution. And remember, a general solution is a linear combination okay, so we have C1 e to the r1x plus c2 e to the r2x, right? So it's a linear combination of either r1x and either r2x, where those two functions are linearly independent. And of course, our roots here are definitely distinct, right? They are different. So we can just say c1 e to the, so r1 is 0 times x, that's an x, plus c2 e to the negative 10 times x. And then, of course, we know 0 times x is 0. C1 times anything to the 0 is 1. And this is just the same. And then it's just C1 plus C2 e to the negative 10x. So this is our general solution to this homogeneous linear equation. And later on, we'll actually call this CY complement. But for now, I mean, it's a general solution to the homogeneous differential equation, because we can have non-homogeneous, which we'll do later. And so this was example 3. I'm trying to think of example 4, which one I did. If somebody remembers which one I did, please let me know. I'm trying to think of, I definitely did, okay, greatest common factor. I have, this one was factorable. I think I did a repeated root on the 5th one. Oh, well, I don't know if it's the same one, but I think this is a good one. Even if it's not the same, I think it's a very good problem. So example 4, let's call it new. So let's say we have, let's see, y double prime, oh, let's see, minus, oh gosh, let's say 4. Let's see, do I want to choose that? Yeah, I do. Okay, so, whoops. So again, let's use the characteristic equation, right, to rewrite this as a polynomial. So this is going to be r squared minus 4. And again, maybe this is an easy one, too easy, but again, please send me an email and let me know which one I did, for example 4, if you'd like me to do it again, since I erased it and I was redoing this. So this is definitely a difference of 2 squares, right? We used this when we did partial fraction decomposition. So r is equal to 2, or r is equal to negative 2. So I'll call that r1, r2. Here are my roots. So my general solution is going to be c1 e to the 2x plus c2 e to the negative 2x. That was fun, but that seemed too darn easy. Well, if you have a problem, I mean, again, you're more than welcome to ask me. Again, I apologize about this whole skipping thing. Not sure what happened there. Okay, I will stop here, and again, if there are any other problems, please let me know. And thank you again, Kendall, for catching that mistake or error.